University of Washington's International Program here to welcome you to our event tonight. I just completed my master's with UW School of Marine Affairs, and next week on Wednesday I'll be talking about my research on climate change in Lake Washington and Lake Sammamish. But I get to have this opportunity because of the special collaboration between Town Hall and UW's Engage program. Together they host the series called UW Science Now as part of the Seattle Science Lectures, and sponsors include Microsoft and KPLU. So now our first guest. Emily Davis is a master's student at the School of Aquatic and Fisheries Science at the University of Washington, where she studies the inner workings of freshwater ecosystems like lakes and rivers. Before coming to grad school, Emily worked as a field biologist in Alaska, the Mojave Desert, San Juan Islands, and the Klamath-Siskiyou Mountains. While not splashing around in her study streams or splashing around in her data, Emily enjoys sea and whitewater kayaking, skiing, and gardening. Emily is also an aspiring science journalist. Tonight she poses the question, can wildfire rejuvenate streams, in her talk, Rising from the Ashes. It's also Emily's birthday tonight, so we should wish her happy birthday. And please give a warm welcome to Emily.
Hi everybody, welcome, and thank you so much for coming out tonight. Thanks Tala for that introduction. So tonight I'd like to talk to you guys about wildfire and how it might or might not be a beneficial thing. So to start off with, I'd like to ask each one of you to take a moment and think of what you picture in your mind when you hear the word wildfire. Maybe you picture something like this: wildfire as a waste of natural resources, as a source of madness. Or maybe you picture something like this: wildfire as a sinister enemy. Or maybe you even picture something like this: wildfire as the murderer of these adorable woodland creatures. And of course, in the modern media, every summer, we're bombarded with images of wildfires raging near San Diego, LA, in Colorado and New Mexico, ravaging homes and properties. These are all negative images of wildfire, showing its destructive and dangerous side. And this is what a landscape can look like after a fire, like a post-apocalyptic moonscape. And just to clarify what we're looking at here, this is not a snowy forest in winter. This is a forest in the middle of summer that's covered in ash. Ash is even in the stream, which is running through the middle of the frame here. So for many of us who have grown up thinking of what a forest and stream is supposed to look like in a certain way, this kind of image can be really shocking. It just looks wrong. So if you find yourself associating wildfire with these negative images, you're not alone, because this kind of thinking has been around for a long time in our national consciousness. And of course, with images and information like this, it's natural for us to think of fire as the villain in our story of our struggle to protect our public lands and to protect our own homes and resources. Fire is an agent of destructive change. It's something to be prevented and something to be put out. And of course, it's natural for us to want fire as the villain to be vanquished in this scenario. Sometimes wildfire wins, but more often than not, it doesn't. We put it out, and that's a good thing. Case closed, right? Well, you might have heard the phrase that history is written by the conquerors, and everybody knows that there's always more than one side to any story. There might be another way of looking at wildfire. There might be a context in which wildfire isn't the villain, but instead, maybe the hero. And if anybody here is familiar with the 1940s comic book character Wildfire, which I wasn't before doing some research for this talk, now is a great time to get acquainted. So according to her creators, Carol Martin, aka Wildfire, goes forth in the dead of night to fight the forces of crime and evil, using her flame whip that we see here on the screen. So this is obviously a very different way of looking at wildfire, one that most of us are totally unaccustomed to. And so this is a very different story than the one I was just telling you about wildfire as the villain. So we've got two pretty different stories here. And ecologists are people who study the natural world, and we investigate how organisms are impacted by their environment. And ecologists are a little bit like detectives. we're often hesitant to accept one version of a story over another version before we go out, gather some evidence, take it back, look at it, argue our case, and then make the call. So which story is it? Fire is the villain? Fire is the hero? Maybe neither, or maybe both. Well, before we can make this call, I'd like to invite all of you to join me for a minute in putting on our ecologist goggles. Our ecologist goggles are going to allow us to step back from the situation and investigate things objectively, gathering evidence. So we might get the untold story of wildfire as we go through this investigation. So I'm one of those people who wants to look at wildfire through a different lens and maybe tell an untold story about it. I study wildfire's impact on ecological systems and specifically on streams. And you might be thinking, why streams? Many people, when they hear the word wildfire, initially think of fire's impact to the trees, shrubs, and animals that live on land. However, aquatic systems like rivers, lakes, and streams, of course, are not separate from the land that surrounds them. In fact, most of what goes on in a stream is highly dependent on materials and energy coming in from the land adjacent to the stream. So because of this intimate connection between land and water, something that happens on land, like a wildfire, can profoundly impact what goes on in the water. So to help lay the groundwork for this important land-water connection, I'd like to give you guys an analogy. One good way to think of this stream-forest connection is like the global economy. So the global economy has a constant exchange and cycle of energy, materials, and products going from one place to another, being transformed from one form into another. For a simple example, we might have some copper ore that we mine in Africa. That's great. Copper is valuable. But we want to get that copper to a factory. How are we going to do that? We need a way to transport it, so we might put it on a ship. Great. Goes over to China, where, as we know, there are a lot of factories, and those factories are going to take that raw material and turn it into something a lot more complex that has a lot more value to us, such as a smartphone. So we could sell that smartphone in Asia, but there are also markets for smartphones in North America, where consumers are going to enjoy that product until eventually it's reached the end of its life cycle. People recycle it, hopefully, and those recycled parts go to somewhere where they're disassembled, turned back into components, and the whole system starts again. So just like the human economy has this constant cycle and flow of materials and energy from one place to the next, the stream forest economy is no different. There's a constant cycle of materials, animals, and energy going from one ecosystem to the next. And just as the human economy is not a stable, static entity, that's why we are constantly hearing about things like the NASDAQ and the Dow Jones Index on radio and TV news. The stream forest economy is also not stable and static. Both have their periods of ups, their periods of downs, but over the long term, they tend to hover around maybe an average of sorts. And just as big, medium, and small human events like war, elections, or even a national holiday can really impact what our economy does, big, medium, and small environmental changes can really impact how the stream forest economy is functioning. So let's get back to our investigation, to our story. Our story starts in what might look like a perfect world. This is what a lot of us grew up thinking that a forest or a stream should look like. It's really peaceful, harmonious, undisturbed. We've got big, mature trees. It's very cool and shady. Man, I can almost smell the pine needles in the air. So this is our ideal image of what this forest should look like. And now let me introduce you to the cast of characters in our forest stream economy. So what makes the forest stream economy go round, of course, is the sun, which is the source of its energy. And because we've got a mature forest here with big trees, not a lot of sunlight is going to get down to that forest floor from that stream, but a little bit is. And if you're a gardener, of course you know that besides light, the other important thing to allow plants to grow is, of course, fertilizer, or food for the plants. And of course, in the stream forest economy, our fertilizer doesn't come in bags. It's just from the soil and rocks around the stream that's going to wash in during weather events. So with these two important raw materials, this energy from the sun and fertilizer from the land, plants can grow in the stream, like this blob of algae down here in the corner. And you can think of algae like the factory in our stream economy that's taking that raw material, those nutrients, and turning it into something more complex and very highly desirable for other critters that live in the stream. So one of those consumers that lives in the stream are baby bugs, like this adorable larval caddisfly here, who is definitely going to enjoy munching on the products produced by our factory, the algae. Another important raw material that's going to come in from the forest to the stream are leaves from the trees. They're going to provide a source of food for other stream insect consumers. And some terrestrial insects, like this caterpillar, are going to meet an untimely end when they fall into the stream. But this is a very important luxury import for our friends the fish, another consumer who's really going to enjoy that. Now, two more raw materials that are very important imports from the forest into the stream are gravel and logs. And you can think of these like the building materials of our stream forest economy. They're going to provide a lot of important habitat and hiding places for the fish, stream bugs, algae, and other critters who live in the stream. When those baby bugs grow up, they turn into adults, like this mayfly here, that are going to emerge, come out of the stream, and fly into the waiting nets of streamside animals like spiders and bats. So you can see that the stream forest economy is really not a one-way street. There's a flow of energy and materials into the stream, but there's also a flow of energy and materials out of the stream and into the surrounding forest. So great, that's our cast of characters. Their goal in life, of course, is to survive and reproduce. So that's what they're doing. They're innocently minding their business, eating, trying to make babies, not making any trouble, when one hot summer's day, a strike of dry lightning hits a ridge top. And it starts a little fire in some dry grass. Pretty soon, that fire is going to be crackling through the leaf litter on the forest floor. And pretty soon, before you know it, it might have jumped up into the treetops. And this is what we call a crown fire. It's a very severe fire. So you've got whole trees going up. That fire is going to start creating its own weather patterns. It's going to race across the landscape quickly, jumping streams, turning the streamside vegetation to a blackened crisp. And if the weather doesn't cooperate, it might not go out until it rains in the fall. So when everything is said and done, our landscape looks pretty bleak. And at this point in the investigation, I personally would be very tempted to conclude that fire is the villain, hands down, no question about it. Let's just go home right now. We've got the soil is cooked, animals have fled, fish are either dead in the stream or they've fled into other nearby streams. Streamside vegetation is gone and things are just a mess. So from our subjective human point of view, yes, things are looking very bad. But let's remember, we've got our ecologist goggles on. So we're going to put these aesthetic notions of what the forest should and shouldn't look like aside, and we're just going to step back and objectively observe what's going on. So the first year after the fire, things are still looking pretty terrible. And one of the first things that's easy for us to observe is that there's no streamside vegetation left around this stream. And of course, this means that the sun can beat in and really raise that stream temperature up. And a lot of the critters that were living in there before, back when it was that shady, cool, perfect-looking forest, probably weren't too keen on hot temperatures. So this might be uncomfortable or even lethal for a lot of our cast of characters. And because there's no plant roots holding down the soil anymore, not only do we have some fertilizer, some nutrients coming into the stream, we're going to have a lot more than normal. And besides just soil, we're also going to have gravel, logs, all that ash and debris from the fire that's going to wash in there during winter and fall rains. And what this means is that for the first year, that stream is going to be a pretty muddy and dark, inhospitable place. It's going to be hard for fish to breathe and hard for algae to grow. So there's not going to be a lot going on in there. But we're patient ecologists, so we wait around. If we have enough grant funding, we can come back for 2 years, maybe 5. And every year, we're going to make some observations and collect data. So after a while, we do see some plants coming back around the stream. This means that there's a little bit more shade than before, but we also have more light than we did initially in the very shady, cold, perfect stream we started out with. And with all those extra nutrients coming in from the land, that's going to enable a lot of algae and plants to grow in the stream, more than before. And if you'll remember, those plants and microbes are the factories of our stream economy, taking those precious raw materials and turning them into something more valuable for stream consumers to use. Two consumers that might enjoy eating that algae are, again, our baby stream bugs and this crazy looking thing, which is a zooplankton, which is basically a little relative of crabs and lobsters that lives in streams and lakes. Now that we have a few streamside bushes coming back, we have leaves falling into the stream, they're an important raw material, as well as caterpillars, which are going to help support returning fish populations. Of course, all those baby stream bugs are going to become adults, which fly off and support the populations of spiders, bats, and birds, which are coming back. And also we have raw materials like dead trees falling into the stream, which provide those important building materials for the homes that our fish, algae, and stream bugs need. So with every passing year, our stream economy is getting stronger and stronger and stronger. And after 5 years or so, the stream economy is cranking away at a much higher rate than it was before. Sure, things look messy and maybe uglier than they did in that first picture of a stream that I showed you, but that's just your aesthetic sense coming into play. If you actually talked to our cast of characters, they would tell you that at this point in the game, they are thriving. Things have really kicked into overdrive. There's more energy and materials both coming into the stream and going out of the stream than there was at the beginning of our story. And the name for this pulse of productivity after a big disruptive event like a wildfire is the fire pulse. As years roll by, after maybe 10 or 20 years, you've got some of that streamside vegetation coming back. Things are going to be shadier, they're going to be cooler like before. And after 30, 40, maybe 50 years, you might have some of the forest canopy returning. So pretty soon you might not even be able to tell that it had burned at all. And things might be back to normal. But after the trajectory of post-wildfire events that I just showed you, can we really say that the forest we started off with was normal in the first place? Often when humans think about nature, there's this pervasive myth of balance that comes into play. And it goes like this. Nature is in this extremely fragile, delicate state of equilibrium when, boom, something comes along, a natural disaster, or maybe even us humans, and knocks it out of whack. Tragedy, catastrophe, etc., etc., etc. But this is really just a figment of your imagination, much like unicorns. It's really just part of a story that we humans like to tell ourselves about how the world works, because we have such a limited notion of time. And any scene that we look at on the landscape is really just going to be one snapshot in time. And I'm sorry if I just burst anyone's bubble about unicorns. Wildfire is just one kind of what we ecologists like to call a disturbance, which is just a fancy way of saying a change in the environment that results in a change in the ecosystem. And there are all kinds of natural disturbances, big and small. Some are caused by organisms, like disease outbreaks or maybe pests like this pine beetle, all the way to a beaver putting a dam on a stream and flooding a river valley, turning it into a lake. Other disturbances are caused by weather, like blowdown from a big storm, or annual flash flooding in the desert. And if anyone is actually from the Northwest, this one will be familiar to you. There's also big geologic events like volcanic eruptions, which turn images like this postcard-perfect picture of Mount St. Helens into this. But for ecologists, this scene is nothing more than a really cool way to investigate how an ecosystem gets up and dusts itself off after being knocked down, how it rebuilds itself from scratch. And in fact, a cycle of disturbance is really the normal state of affairs. Most landscapes are in a constant state of flux. Nature is very dynamic. So in one landscape alone, you might have areas that are in all different parts of the disturbance cycle, going from this initial, very mature forest that I showed you, to the disturbance itself, like a major wildfire, to the reorganization state after the disturbance, and all the way to that fire pulse, a few years after the disturbance when things are getting reorganized and kicking up again. And then, of course, back to the original. So we really need landscapes that have areas in all different parts of the disturbance cycle to create a diversity of habitats and available resources for different plants and animals. You could think of this like a mosaic or a patchwork quilt on the landscape. So I work in a remote area of central Idaho in the Frank Church Wilderness, where wildfire is an extremely important part of the disturbance regime on the landscape. So here we're looking at the land from a small plane, which is how I got to all my research sites. And you can see that all of this land has been burned in some way or another over the past 30 years, and sometimes more. So we're flying over the main river, and you can see smaller streams coming in on the sides. And all of these streams have been burned in different ways. Some have been burned more than once, some have been burned more severely than others. Some have been burned more recently, some more long ago. And so this is truly a disturbance mosaic. It's really that patchwork quilt, and it provides a priceless natural laboratory for people like me who want to go in and investigate how different kinds of disturbance impact that stream forest economy. So, can we make the call about villain or hero at this stage in the game? Is Wildfire the bad guy, or is Wildfire wearing a really cool outfit with really long hair? Well, I think that villain and hero might even be putting it in too black and white of a framework. It might be a little bit of a false dichotomy. This disturbance isn't necessarily always bad or always good. It's really just an agent of change. And you can't deny that ecological disturbances like wildfire can be destructive and dangerous. But if you look at them in a different light, especially over the long term, you also can't deny that they have a lot of positive benefits. So if we can learn to tell the story differently, if we can look at wildfire as not always the villain, can we change how we react to it? If we know the potential positive benefits of wildfire, can we change how we manage it so it can benefit ecosystems like streams, which will ultimately benefit us? And if I were going to turn the story of wildfire into a blockbuster movie, I think the previews would sound a little something like this. In a world where nothing is as it seems, one underappreciated heroine must rise against prejudice and suppression to reshape our lands and waters. Maybe for the better. Thank you. I will take any questions.
We have about 4 minutes for questions. And just as a reminder, if you could come up to the mic, we're actually recording this and we'd love to capture it.
Thank you for explaining the complexity of ecosystems and how wildfire interacts with that. One of the things that I think is tough for society to accept this is that we depend on certain ecosystem services that forests and streams, natural areas produce for us. And one of them that I'm very familiar with is in Colorado, in the Front Range. There's so many standing dead timbers from beetle kill because we didn't allow fire in there for so long. So how do you address and allow fire to happen in that area where if one of those matchsticks goes, it'll probably light up the whole Front Range and the water of Denver and Fort Collins and Colorado Springs is pretty much poisoned?
Well, my answer is going to be a little bit of a cop-out, which is that your question is excellent because our next speaker, Brooke Castle, will be speaking to that very dilemma. But I would say that the best thing is just to ensure that you really have that patchwork quilt, that disturbance mosaic on the landscape so that it's not all or nothing. And obviously it's hard to just snap your fingers and have the perfect situation, but we can manage for the future so that in the future we don't have forests that are just matchsticks waiting to go up.
Excellent presentation. I have two questions. Your presentation seemed to focus on the role of catastrophic fire and how those affect streams. I was wondering what the role of like smaller, more frequent fires might have to do to streams. For example, like in southern Washington or Oregon, you might have like more regular fire intervals and just not necessarily devastating fires.
Mm-hmm. So people have actually done experiments with this where they've set prescribed fires and then measured the impacts on streams. And prescribed fires are usually lower severity, like the fires you're mentioning, with more frequent return intervals. And what they found is that low severity fires really don't have much of an impact on streams. And the reason that is because one of the major reasons that fire does have such an impact on aquatic systems is because severe fires take out the riparian area, that streamside vegetation, and that lets in more light. It means that more soil and gravel can wash in from the hill slope, and if your fire isn't severe enough to burn through that streamside vegetation, you're just not going to see much of an impact. So fires aren't always going to have this impact on streams that I walked you guys through today. It's mostly only going to be more moderate and severe fires that do that. So it is important to have all different types of disturbance on the landscape, from that low severity fire to the high severity fire.
And my second question was, do you think it's more useful to talk about streams from a perspective of like successional theory in terms of stable states, or more useful to talk about them from like a chaos theory, like thinking about them in being constant change?
The answer is yes to that question. Yeah, they move, and so a disturbance at this part of the stream isn't just going to impact what happens right here, it's going to also impact what happens all the way down here because that water is moving. And so that's kind of an emerging field of research that people are still looking into. It's like, how do we even measure that, you know?
Thank you.
Fortunately, that's all the time we have.